So yeah, there's only a couple of us. So like I said, I'll just do a kind of speed run of the two items I had. And then if that's it, then it's a reasonably short video for other people to watch. So first of all, we're working on being able to migrate from having one queue per worker to, or one worker per queue, to multiple workers per queue, so that we can drastically reduce the number of queues we listen to on Sidekick in production, which should give us a big reduction in the CPU saturation as well, because the current CPU saturation is basically some combination of the number of queues we listen to, the number of clients we have, and the distribution of work within those queues. And of those, the easiest one for us to affect downwards is the number of queues we listen to. So Wangmen's done most of the work on this in terms of allowing queues to be, workers to be routed to different queues. So by default, a worker will go to its own named queue as before, but you can set some configuration that will say, actually, this job should go to this queue. And so then the migration becomes fairly sort of simple to think about. You set those configuration changes, you wait for the old queue names to drain, and then you stop listening to those queues. But there is a wrinkle, which is, oh, I need to remember what this set is actually called. Oh, gosh. So there is a wrinkle, which is this, in Sidekick, there are two sets, or there are actually four, but there are two that we care about, of jobs that are sort of global. So we have this sorted set for scheduled jobs in the future, and we have a sorted set for jobs to be retried, and there's also interrupted and dead jobs, but we don't care about those so much because we don't really do anything with those on GitLab.com. But those are things we need to deal with, because in those sets, the entries have, gosh, this is a bad explanation. Those entries contain the queue name as part of the JSON payload. So if I take a look in here, you can see that this is going to the background migration queue, and this is going to the background migration queue. So what that means is, if we just stopped listening to those queues and then something gets popped off the scheduled set, that would go to a queue that we don't listen to, and hopefully we'd alert on that, but we'd lose it. So I just wrote a rake task to address this. I don't know if it's going to be useful to show the rake task really, but I'll just show what it does first. So yeah, I'll just talk through quickly what it does. So basically it just uses scan, or zscan, because it's a sorted set, steps through the set, looks, it just uses the queue configuration that you've already set up, the worker configuration for the routing. So it just says, like, make the scheduled set queue names and worker names match the queue names and worker names from the routing configuration. I was thinking about allowing arguments, but I think it's just simpler to just say, you just run this, and if your configuration is what you want it to be, then it does what you want it to do. There are 20,000 jobs in the scheduled set I have locally, and that took a couple of seconds. There are like 60,000 in production, but obviously nothing else is using this Redis at the moment. I'm not even running Sidekick right now. I'm just running Redis and a console. So it might take longer in production, but that's the basic idea. So that there's also a equivalent task for the retry set. So the idea there is you sort of add a couple of steps to that migration. So it's like, set up the new configuration, run these tasks to migrate the scheduled sets and the retry sets, wait for the queues to drain, stop listening to the old queues. So yeah, that's the basic idea there. And that's in review now. So hopefully that can be merged soon. Yeah, any questions on that?
For the rake task, did you? I'm curious how how long the longest single Redis operation lasts. It wasn't the entire multi-second duration, was it?
Oh, no, right. So yeah, sorry, I meant to explain that when I started saying it scans and then I stopped. Yeah, good question. So it uses Zscan, which is, or Zscan, let's just say scan, which is O1, I think. It uses then two log n operations, which is the remove and the add. It's slightly annoying to me that you can't remove by key and by score. So I just have to remove by key because obviously there could be several jobs scheduled at the same time and I might only want to remove one of them and we can't edit it. It does also check, because like this set represents work that can be popped, it does check just, the return result of what happens when we try to remove it, and says, okay, if we tried to remove that and nothing got removed, don't add it back so we don't double schedule the same job. And yeah, I guess technically you might need to run that rake task twice. I forget what the scan guarantees are on like, oh no, you shouldn't need to run the rake task twice, because by the time you run the rake task, you've already updated the configuration. So anything new going into that set is going with the correct.
Goes to the new, yeah. That makes sense.
Yeah.
Yep.
So yeah, that's the basic idea. I've written up some administrator documentation for this, but like I said, it's still in review. But I also realized today I should probably add this to the run books, because this is also in issues, but I think it's going to be useful if we put it in the run books, because then I could just be more specific about what we want to do on GitLab.com rather than the general, you as a generic GitLab administrator, this is what you do here. So yeah, that's that one.
So a question for you, like a generic GitLab administrator or operator rather.
Yes.
Would have to do this? Would have to do this?
Only if they want to do what we're doing. So
okay.
We're documenting this, like this is optional at the moment. The eventual end goal would be that we probably do something automatic if this works well for us, but we could leave that for like a while because we still have the queue selector, and the idea is that we don't need the queue selector if we do this, because you will be listening to a handful of queues and there will be these virtual queues, I guess,
yeah,
that are configured, like, that are rooted within the application itself. But yeah, it's not a high priority to move everyone over to that way of working, I don't think.
So just a quick, I don't know how to call it then, but reading the document that you placed in that merge request, it was nearly impossible to me to figure out whether I should run this or not.
Right, yes. So part of the problem there is I linked to a document that is not in that MR. It's in another open MR that Wang Min's created, but also the documentation is what I'm fixing in that today, because at the moment it doesn't really work. All
right, so you're aware. I think that's okay. Okay, that's the important part. Thanks.
Sorry, I'm just making a quick note of what we discussed. Okay, so I've got the next thing as well, which is about how we actually roll this out. So I spoke to Craig about this, and we talked a bit asynchronously, and then we had a chat yesterday evening my time, yesterday morning his time, and so we wanted to like clarify a couple of things. So first of all, the scope of the project that we're working on at the moment, we said catch-all initially, which is kind of ambiguous because we have two catch-alls. We have one on VMs and one on Kubernetes, and they listen to different queues. We're making it explicit that this is for the Kubernetes one. That one listens to more queues already. I made a recent change with Scalability that means that by default, new workers go to Kubernetes rather than VMs, because obviously we don't want to add new stuff to VMs that potentially might not migrate to Kubernetes. That's kind of a nightmare. So like it's much better if it goes there first. And of course, you know, migrations in general are going from VMs to Kubernetes, not the other way around. So we're making it explicit. It's about that. I also, Andrew, you might remember a while ago, we stopped listening to some queues on GitLab.com to get a small CPU drop on the Redis sidekick. So there are like 400 odd queues, and we figured there were like 30 to 40 of them that we don't actually use in production, like some geo queues, some of the chaos.
And if I recall, we've got some funny alert that if anything ever appears in those queues, we'll generate an alert.
Yes,
yeah,
exactly.
That's
so
the same thing. Yeah.
Part of this, we can remove that because obviously we just won't be putting anything in those queues anyway once we're done. But I also realized
and the alert.
Or we were listening to those on production until like Monday when we fixed that. So we like undid that change as part of some of the migration stuff, I guess.
Is that because we've gone across to like using like literally every named queue and actually going away from, at least for Kubernetes?
Yeah.
Is it related to that?
Yes. So I've done some, actually, I'll just share real quick. I've done some changes based on that. Oh, that does not link to the right lines. Yeah, so this is now simpler. So like it's still quite a long selector. Wait, I'm not sharing.
Are you intending to share your screen?
Sorry, yeah, I forgot to actually click the share button. So catch-all used to be like it was literally like 9,000 characters long. Now it's the concatenated list of the other shards, including I just tagged all the workers that we don't currently run on Kubernetes, so we can put them there. That's still not ideal because it means in the application there's a thing that says exclude from Kubernetes, and there's no actual reason to exclude most of those from Kubernetes, except that that was what we were already doing. So this needs to be a temporary situation, not a long-lived situation. But for now, it makes that a lot simpler to reason about. And then we've also got an exclude from GitLab.com tag, but I think I might be in the wrong. Yeah, I think I might be in the staging file here. I can never remember which is which. But anyway, we added that exclude from GitLab.com tag to some workers as well. And again, the idea is that's temporary. I actually applied that to staging and production. And then it turns out, I should have realized, we actually do use geo in staging. So the geo team were like, wait, what? Why is nothing working? So yeah, but the upshot of that is, we got like a, I don't know, 1% drop in CPU.
That's what I was going to ask. What do we see on the?
Oh, actually, I
CPU?
can show that. Let me share again. Once I find the chart that Craig posted, I think we posted it in here. Yeah, there we go. So the lower line is after the change, and the above line is before the change. So this is week on week. Sorry. So that's, you know, it's a drop. It's not really gonna make any headlines, but like we did save that CPU back. The other thing is that we can use these queues to test on staging, because if we set up routing rules for those to go to default on staging and production, on production it won't do anything anyway because we don't process any of those workers, and on staging it will do something. So it's quite a nice way of like having the first part of the rollout be something that would only affect staging anyway. Like, I'm not saying we make the change on staging at the same time as production, but even if we did, it wouldn't actually be impacting production. So that worked out quite nicely. So yeah, the plan is we'll basically do those. We'll then define. Sorry, I should just keep sharing my screen instead of turning it off and on. So the way the routing rules work is that they're global. And obviously, Andrew, you'll know this because we talked about this at length like a year ago. But they're global. So at the moment, each sidekick shard only knows which queues it processes. It doesn't know which queues other shards process, which is why we have that negate selector where we concatenate all the others and we say anything that's not in this doesn't match any of the other selectors, do on this shard. But because this is global, we can just say we can match stop at the first one that matches. So this is a priority list, which means we'll have something like this initially where we sort of define all these shards, and null just means match the rule, but don't change the queue name. So we can have them all there, and then exclude from GitLab.com can go to default because that's the way we can test on staging. And then as we want to roll this out, we can just add selectors up here. We don't need to combine into one mega selector. We can just add. So the plan there was...
Sean,
oh, yep.
Sorry, so where is this config specified, just so that it can help me sort of
oh, right. So
grasp.
yeah, this is in GitLab.yaml in the Rails apps.
Okay.
It gets there via Omnibus or via charts. So yeah.
Yeah. Okay. Thanks.
Yeah. Yeah, so this would be the sort of initial state. So we're routing the ones that don't do anything on production anyway, and everything else ends up in null, which means that, like, you know, the rest of this is essentially no ops. It's just to make it clearer to people what's going on. After that, we can go to you know, actually migrating workers that do stuff, and we're not like set in stone on this, but one way we thought might be reasonably neat might be to do it by feature category, because we have some feature categories that represent some sort of fairly low volume workers, and then we don't get back into the situation where we have like a bunch of things selected by name that we then need to untangle. We can just sort of do it by feature category. And if it breaks something, we only have one team to talk to when we break it, because only one team will own that feature category. So that was sort of a nice thing. It's a shorter selector, and yeah, and then once we get to the final stage, we would be simplifying again, because we'd be removing.
Sorry.
Yeah.
This is probably a stupid question, but with that feature category, there isn't any sort of like division by CPU bound or.
No, so these would be below these. So if it matches,
right, okay,
yeah,
it's only the catch-all ones effectively.
Yes, so sorry.
That it's filtered. Okay, sorry, that's why it was probably.
Yeah,
a stupid
no,
question.
sorry.
But okay, that
well.
clears it up. Yeah.
Yeah, so we'd be adding the feature category rules above this bottom, which is
okay.
the selector here, so that if it matches any of the other ones, we still don't.
It just goes to those CPU
exactly.
and everything else. Awesome.
And I think that's kind of a nice model, anyway. Just in terms of like I said, understanding what it does. It's just like read it down until you find one that matches and then stop. And it does mean that we can do things like this where we can just add that arbitrarily in there, and we don't need to change everything else to fit. And then at the end, we would delete this line, delete any feature category lines we had, and just change this null to default. And it should all work. Job done. So yeah, the end configuration should be fairly simple. At that point, we then need to decide like if we want to go through and like allow arbitrary queue names to push these to, if we think it's going to be worth it or not. But if we do decide it's going to be worth it, it would be fairly quick to do. So we might. And
there's no, I think the answer, I know the answer to this, but you've probably thought this through a lot more. There's no sort of risk from the speed at which that config change is going to get rolled out across VMs and Kubernetes pods is probably going to be quite vastly different.
Yes. And
there's no risk in that, is there?
Right. So that is actually a very good question. So when I sort of skimmed over at the end there, I said like this is fairly straightforward to do for the other ones. The thing with the other ones is we would need to add a new queue and start listening to that queue before anything showed up in it, right? Because we'd need to say, listen to all the queues related to, say, project export, but also listen to this dedicated queue that will contain all the jobs for project export once I've done this next thing. So we need to like make sure we do that in 2 steps. For this one, specifically, we pick the default queue, which is there and is never used for anything, but is already listened to by the catch-all nodes. So we're going to get that for free. And that's why we picked the default one, because...
Okay, yeah.
Takes a bit of effort, basically. Yeah.
Awesome.
That's a freebie.
So, just consider if it doesn't go that way for some unexpected reason, it might be valuable figuring out how to pair with delivery to actually get the rest of the VM Sidekick queues over to Kubernetes because we don't have a blocker anymore for it.
Yeah, no.
There is still pages, but I mean, I just read a comment that that's not really a blocker, so it's a bit undefined, and it would be good to define it.
Yeah, Craig and I were actually talking about that yesterday because I think the pages thing is like, it's, well, Jav will know because he's also on that issue. It's a temporary directory that happens to be on the NFS mount, but we don't think it needs to be on NFS. It's just that that's where it happened to be historically. So
Think or no?
Well,
No, we know. I mean, I think what maybe you said this, Sean, like it made sense for it to be there because you're moving temporary files and you want to keep it on the same volume.
right, exactly.
So,
you don't want to move from local disk to NFS if you could just operate in the first place.
So I think that was a smart decision at the time. It's just that we're still using this as a temporary scratch space. So we're thinking about just reconfiguring the page's root directory to be somewhere else other than the NFS mount, which will write the temp files to the root partition where we have like on average 10 gigabytes free. We're thinking that's okay. I mean, another option would be to expand the root volume temporarily.
Partition.
Yeah, I mean, it's either root or var log. Those are two options. We could create the temp directory or we create the page's root directory in var log. It just feels weird. Maybe that's a better option now. If this is only temporary anyway.
Yeah, I don't know. It's just some old school part of me which has had that beaten out of me.
Yeah,
Putting
yeah, no,
those kind of things in the root directory.
Yeah, I mean, they're both, neither one's an SSD, as I recall, and one is much larger than the other. And there's a meaningful consequence to filling root, and there's not to filling var log. So yeah, go with SA for root, even though the name
Go
is,
with var log.
Yeah, that would be my vote.
Okay, yeah, I think since this is temporary until we move this to Kubernetes, where we'll have like
We can hold our
limit.
nose.
Yeah, exactly. So maybe we'll go that route.
Yeah, one thing on that move point, Jav, that I realized after I posted that was like, yeah, it makes sense that like, you know, if you want to move a file from temp to thingy, you know, you don't want to move it across mounts, like, you know, it's on NFS from the start to finish. But with object storage, like obviously that wasn't an option anyway.
Matter.
So like
it
we
doesn't
have
matter.
to do that with object storage. So like, is it really that bad?
Yeah, I assume this is just like it's the reason originally was for that, and now it doesn't matter anymore. Yeah.
Cool. Yeah. So Marin, Craig and I did sort of discuss that briefly yesterday when we spoke, because we were like, the other thing is once we've done catch-all on Kubernetes, the next best target is to stop listening to all the queues on catch-all VMs. And one way to do that would be to give catch-all VMs its own queue and like migrate to this. But another one would just be to migrate. I say just. It's a big just be to migrate those jobs from VMs to Kubernetes and get this as a result. So yeah, we think that would be the natural next biggest impact, assuming this makes a decent impact. So yeah, I think carrying on with the Kubernetes migration there makes a lot of sense in sort of avoiding double work. So, yeah.
Yeah, I might see if we can prioritize that like sooner, because as soon as API is in production, we could like take a short break from the next service, see how API behaves, and while we do that, just migrate all of the Sidekick and be done with it. Make it simpler for everyone. Cool. Thanks for explaining, Sean. Appreciate it.
Cool. So yeah, that was the Sean show, I guess, for the demo. Does anybody have anything else they wanted to talk about? Bob had something on the agenda, but he's not here. All right, I'll upload this shortly. Thanks, everyone. Have a great day.
Thanks, Sean.
Yep.
Sorry, Andrew, did you want to go? No.
No, it's something that I just crossed my mind, but it was reminded by Bob's thing. And does anyone know about, it's more a question than anything else. Do we have any observability around SAML? Because there is a thing that's happening today. We had an incident and I looked at something and I saw that I actually blocked an account that wasn't causing the incident, but that's a thing for another day. But actually what it is every time this person uses the API, It uses 400 megabytes of memory. And Heinrich looked at the request. He said, "There's nothing in this request that uses 400. It makes a GitLab call." And then we realized that the customer is using SAML, and it's also using like 6 seconds of CPU every request, which is really crazy. And so I started looking around. I couldn't find anything in our logs, and I couldn't find anything in our metrics for SAML, and that's kind of scary.
Yeah, I don't think we have anything like. I do know that some of the responses for SAML I think can be big, but I don't know why that would be when we make a GitLab request that happens. So yeah.
No, but I think it's before the GitLab request.
Oh, for the authentication step.
Step first, yeah. So okay, I'll probably open up an issue about that.
Yeah, I think it would be worth speaking to that team as well, which I guess is the access team, because like they would want to know what's happening here as well, right?
Yeah, totally. But I was just thinking of putting it in. Yeah, sorry, go ahead, Matt.
Yeah, was the SAML operation also correlated with the CPU burn you observed? Because that's an enormous amount of CPU time.
Yeah, I mean, it's up to 7 seconds. So I don't really know yet, and I haven't had a chance to look at it in much detail today yet. But the call itself is really basic, and actually the call fails because there's no repository. So it's not, there's like literally, it should be a 404, but it's a 500.
The GitLab response is not big, is what you're saying.
Yeah. The GitLab response is like not found. And that's all it's doing. And so there's something else for these. The only other thing is I think it's an API token, but I don't know how API tokens interact with SAML, because presumably you get the API token from GitLab, not from SAML, but it probably has to do some dance there. But yeah, I mean, if their SAML provider is giving back like a 50 meg chunk of JSON every time we call them, then that's not really that good. But I'll open an issue about it.
Yeah, I don't know. It would be interesting to find out, though.
Yeah, the thing that Bob opened is also really weird, and that is that the Redis durations all exceed in the logs exceed the total duration. So or often. So I don't know what's going on there.
Well, it's not only that it exceeds the total request duration, it's that we have 4 Redis duration fields like Redis cache duration, Redis queues duration, Redis shared duration, and the total Redis duration exceeds the sum of those as well, which is like they're measured in the same. They use the same thing to measure that. So I don't know how that's gone wrong.
Yeah, there's something breaking there.
Just on the SAML one, Andrew, is it possible?
Yeah.
Like, I mean, I guess you'll look into this when you create an issue, but if it's SAML, there's a decent chance it's a customer. Maybe we'll be able to get support to help them like reproduce this for us. Which would be
mean, I think this particular customer looks like they've got 6 accounts, and so they're probably using like, I don't know, a SAML provider. But it would be interesting to, especially now that we've already reached out to them to tell them that we blocked their account. It would be like interesting to figure out what's going on there. But yeah, I'll open it. I mean, what I was imagining was that we have like a SAML duration or something like, or SAML size or SAML response time in the logs for the request. The only thing I'm a little bit worried about is that we're getting a lot of fields in the logs now. And is that a bad thing? Obviously, there's a lot of good that we get, a huge amount of good, like all the mechanical sympathy logs and like, but there is also like and we can pinpoint exactly, which request is bad, and we can do all sorts of good things. But do we just keep adding like all of these things to the access log?
I don't know. Like, I mean, I guess part of the point of structured logging is that you have one log per thing. With like everything attached to that. But we do have very, like in database terms, we have very wide logs at the moment. So
I think we would probably add one more. It's not going to hurt. But
that's how you get wide logs.
Application settings table.
Yes, exactly. Just one more. There's already 100 fields in here. What's one more?
Yeah, exactly. All right.
Great.
Cool. Thanks, everyone.
Have a good one. Bye.